So now let's take a look at what are the key gates for your CI/CD pipeline. If you missed our previous video on CI/CD, you absolutely must watch it before watching this video. So we talk about ruthless automation and the various phases of a CI/CD pipeline between planning, development, testing, security, all the way to operating and monitoring. The CI/CD pipeline has key phases that are defined to ensure that your software is functioning the way it should, but also to assess its security as well. Each phase has various gates that your software will either pass or fail. You must define what threshold will be for each. Software that passes the gate will continue to the next gate, all the way to production maybe. Here are the key pipeline gates that you must pay particular attention to. So like we talked about, each gate needs to have thresholds, and these thresholds are usually based on your risk tolerance for a specific microservice, based on the criticality of the service and its data. You're going to decide accordingly to set the right threshold. So now when you think of the three most critical gates, you're going to think of change management, testing gates, and cyber gates. So when you look at change management, what you think about is how many set of eyes do you need to go and approve a code change? If everything is code thanks to the GitOps concept, and if you missed the GitOps video, go check it out. But if everything is code, effectively, all you got to do to ensure you have a proper change management concept is to simply have the right set of eyes to approve a change. If it's a basic change, you may just have two set of eyes, never one, by the way, because you never want to be in a situation where an insider threat could create issues in your system. So you're going to have at least two set of eyes, maybe three, maybe four, maybe five. And that's your change management gate. Each microservice could have a different set of number of eyes requirement based on the criticality of the service. Now, when it comes to testing, you're going to see unit testing, integration testing, end-to-end testing, and regression testing test coverage requirement, meaning how much of your code needs to be covered in test to demonstrate that the software is behaving the way it should be behaving automatically with no human in the loop. And the more you increase your test coverage, the more you're going to be able to demonstrate that your code is behaving the way it should. Of course, if you have what we call a digital twin, a full replica of your stack on the cloud or as a digital replica, you can now demonstrate that the software will be able to run on that digital twin and behaving the way it should through those automated tests. That's effectively what SpaceX is doing to be able to do 17,000 software tests a day plus 300 loop testing a day on the actual rocket. So that's something to pay attention to as well. Of course, you have the test coverage gates to demonstrate you have the right percentage of testing, but then you also need to be passing the tests that you have. So you need to ensure that the tests are passing and that your code is able to perform the way it should. And the next set of gate is about cyber gates. You're going to see the most common ones: static dynamic code analysis, so passing those scans and defining threshold of pretty much criticality levels based on the severity of the findings. You could say, any finding that are higher critical, you either need to fix it within number of hours or you need to fix it before going to production based on the criticality of the system. So you can really decide what is acceptable versus what is something you need to fix within a few days, a few hours, or just something maybe you have a little bit more time to address. The same thing would apply to container scanning and just software bill of material scanning, knowing your dependencies and maybe vulnerabilities associated with those dependencies. So you can now proactively update or swap dependencies based on the CVEs that you're going to find inside of these scans. And you can do the same thing based on the criticality of the findings. You can decide whether or not you accept the risk, you mitigate the risk, or you just reject the risk based on your appetite for risk. Now, there is something called data-driven risk management. It's about making the right decision with the right data so you know actually what you're deciding. Too many people just put their finger up in the air, hope for the best, and make a decision. That's just not good enough when it comes to cybersecurity and fielding critical systems in productions. You want to have the right data, the right metrics to be able to make the right decisions so you can move at a pace of relevance with baked-in security. So now there's really a couple of thoughts when it comes to data-driven risk management. First, we're moving from what we call a compliance-driven risk management to something that's a little bit more structured with data, automation, not stuck in time documents that are often stale and behind and not reflecting the real risk of the system. You also want to be able to have those documents to be self-generated on demand from machine readable and human readable data. And then of course, you need to be able to support risk response decisions. What we mean by that is you need to be able to see kind of the different risk factors and get your current status and the ongoing insights that you must have in terms of your security control effectiveness. So you're able to track kind of your security gaps and also where you're doing well and where you need to improve your cyber defense and your cyber posture. Of course, all of this is driven through transparency and repeatability, and all parties, whether it's developers, operation teams, cyber teams, can access the information they need when they need it, ideally through automated dashboard and reports. It's repeatable, it's deterministic, all parties understand the required and optional steps, the outcomes are consistent and predictable, there's no drift in the process, it's enforced through configuration change management on code with artifacts, images, and containers through those control gates, and with the concept of least privilege baked in. So really, the beauty there is by embracing GitOps, every change is in code, and with a change management enforcement, multiple set of eyes to approve a change, you have direct visibility and enforcement capacity to make sure that a single malicious actor is not able to drastically impact your current state and your cyber posture. There you have it. 3 main gates: change management gate, testing gate, and cyber gate. Work with your teams to find the appropriate, not too high or not too low, threshold for each of these gates to ensure that you can assess the functionality and security of your software. The more mature your team becomes, the more it is important to raise the bar and continue to expect better and better and increase the threshold numbers. It is also important to ensure that these numbers are achievable and not some fallacy created by your cyber teams. Otherwise, they will need to cheat to pass the gate and it will defeat the whole point. You want to be reasonable. You want to make sure they can achieve it and it's realistic based on your current maturity. And even if you're not very comfortable of the current state, this is where you are. So you want to embrace that and raise the bar along the way and not make it an impossible feat. Make sure each repository or microservice has its own set of thresholds based on the criticality of the service and its data. That's very important to understand that ideally what you want to have is those thresholds being customized for each service. You must also think about a process to force those gates to pass in case of an urgent need, which would involve obviously multiple set of eyes approval to create some kind of whitelist to force the gate for a specific use case. Maybe there is a 0-day and maybe you need to, you have no way to patch the system and you must still move to production. So you want to have a way to bypass effectively that gate through a very stringent whitelisting process, of course, with multiple set of eyes to approve that bypass. And don't forget that all these changes to your CI/CD pipeline are done in code as configuration as code in Git. So make sure your team uses multi-factor authentication and least privilege to assign rights to repositories, to your team members, and sign their code commits every time so you know who is doing what and when. And you can track the changes and enforce that kind of change management process throughout the enterprise. And this is it. The critical gates for your effectiveness and your baked-in security inside of your CI/CD pipeline, so you can move at a pace of relevance and make sure that you're not doing so in a vacuum or creating unnecessary risk to your mission software and your teams.